This is our Nanovia standard tribometer system. It's 60 newtons, 500 revolutions per minute. Basically, to give you a brief overview of the system, this is the standard pin-on-disc system. This is the ball holder here, and this is the arm with a strain gauge located here. Basically, how the system works is that the disc spins and the deflection of the arm is measured, and then it's recorded onto the software where you'll also get a graphical view of it. To just give you a brief overview of the software here, this is how you have an option to start either a linear test or a pin-on-disc test. Then you go ahead and you have a section where you can put any information for your sample as far as the sample ID, what kind of coating, what kind of substrate it is, the thickness of your coating, and so on. That is just relevant information for your purpose only. You do not need to have that information. It is not vital for the testing. As far as the more important information, you will need to go ahead and input what kind of geometry you're testing as far as your static sample. You can have it a ball, you can have a pin, a flat pin, or you can have a flat-on-flat test. All you need to do is pretty much just be able to adapt that onto our ball holder. Then you would also need to input the type of material that you're testing with. So in this case, that would be the material of your ball. In our case, it's a stainless steel ball. It's going to be a 6mm ball, which would be input here. And then it has a section whether you're going to clean it or not, as that could be important to the results as well. All this information is here just so that the repetition and the simulation for each test is consistent. Then on our test configuration section, you have a section where you're going to input the weight, the radius, the speed in which you want your test to run at. As I said, this one's a 500 revolution per minute tribometer. Then you would also need to input the time. We have section slots for day, hours, minutes, and seconds, all of which you can run the test for either days or you can run it for seconds at a time. You can also go ahead and do the duration based on the distance, which is measured in meters, or by revolutions. Okay. Then you can also go ahead, and once you've decided that this is the type of testing you're going to do over time for a large project, you can always go ahead and set these parameters as your default parameters. Then every time somebody needs to make any changes, you can just go ahead and load your defaults, and automatically you'll have the same testing parameters as you indicated at the beginning. Okay. Then once everything is set up, you're able to start your test, and your graph will go ahead and appear on the screen itself. We'll go through that in just a minute. We're just going to go ahead and come back to the hardware itself. This is where the arm needs to be leveled for each and every test. As you can see here, if the arm is too high, then the level is off. If the arm is too low, the level is off as well. This basically allows you to have an even test without tampering with your results from the beginning itself. So you want to have as ideal of settings as possible. Here you have a lock for your arm. Basically, this allows the arm to not go higher than it really needs to at any given point, just to avoid any flapping back and damage to the arm sensor itself. This is the place where you would go ahead and mount your weights. Basically, what the ideal way to do it is you would go ahead and put a rubber ring first. Then you would go ahead and mount one of your weights. In this case, this is a 1 Newton weight that I'm going to go ahead and mount here. And then you would go ahead and mount another rubber ring. And then you would go ahead and tighten everything. And this is basically used to avoid any vibrations from the weights freely moving up and down or bouncing on the ball holder itself. As far as mounting your sample goes, in this case we're going to go ahead and unlock this here. Move the arm back. As far as your sample goes, you can go ahead and mount it directly onto here with the different clamps that are given to you automatically. Basically, you would just go ahead and set the clamp down on the edges of the sample, and you would go ahead and place it in place. Go ahead and give me 1 second. And having these different holes actually gives you a very large flexibility as far as what types of samples you're able to mount onto your disc. So your sample is now firmly mounted. Now the best case scenario would be to go ahead and clamp it from all 4 sides. So you would go ahead and briefly go ahead and clamp it from all 4 sides. Another then you would go ahead and bring your sample down here, and you're able to do a certain radius.